Hi, I'm Clara Rus from the Finder project, which stands for Fairness and Intersectional Non-Discrimination in Human Recommendation, a research project founded by the European Union that offers free and open methodologies, tools, and training. We offer a free course on fairness, accountability, transparency, and ethics of AI-based human recommendation, and this video is about fairness in learning to rank. In this lecture, we will briefly describe learning to rank and how it can be made fairness-aware in both offline and online settings. Learning to rank is about learning a ranking function that can be used to predict the relevance of each candidate in the context of recruitment. Relevance scores reflect a candidate's predicted fit for a job. Candidates can then be ranked by sorting this relevance score in decreasing order, placing the candidates who are predicted to be most qualified at the top. A learning to rank model is trained using training data consisting of feature vectors and known relevance labels. An offline learning to rank approach is shown here, meaning that the training data has already been collected offline. At inference time, the model makes predictions on test data consisting of feature vectors from different candidates. The resulting ranking can then be evaluated in both terms of utility and fairness, meaning that the ranking should be useful for the recruiter but also fair towards groups defined by the sensitive information such as gender, nationality, age, and religion. But how do you produce a ranking model that outputs a useful but fair ranking? In addition to the training data collected in advance, learning to rank models can learn from users interacting with real systems. This is called online learning to rank. In contrast to offline learning to rank, this has the advantage of not requiring separate annotations because we use interactions with a live system. Or we can capture the preferences of a user using the system, and that does not require showing potentially private data to annotators. Online learning to rank creates some new challenges too. The core problem is that users' interactions with live search systems are inherently biased, so the interactions need to be debiased before they can be used as training data. An example of position bias is shown on the right-hand side, which shows eye tracking of search results. Users are more likely to click results at the top few positions than they are to click results later in the list, regardless of whether the top results are actually relevant. There are many other biases as well. Propensity-weighted learning to rank is one approach for debiasing interactions. The general idea is to obtain propensity estimates and then use these estimates to debias the interactions that were observed. Intuitively, using this approach to mitigate position bias would mean that clicks on top-ranked results are down-weighted and clicks on low-ranked results are up-weighted. After debiasing, interactions can be used as training data. Now, how can we make learning to rank more fair? These are various fairness methods that can be applied in the pipeline of such systems, including pre-processing, in-processing, and post-processing methods. Pre-processing methods are applied on the data representing the candidates, meaning the feature vectors. In-processing methods modify the learning procedure to jointly optimize a model for both utility and some notion of fairness. Post-processing methods are applied to a generated ranking to make it more fair. Only post-processing methods can guarantee fairness. In this lecture, we will provide an overview of state-of-the-art mitigation methods, and examples include IFAIR, a pre-processing method based on the idea that similarly relevant candidates should have similar feature vectors, DELTOR, an in-processing method that uses a dual loss to optimize for both fairness and utility, and FAIR, a post-processing method that aims to ensure the best candidates from each protected group appear in top positions. Another example of in-processing online learning to rank can be made fairness-aware. As before, this starts with debiasing from a live system. A fairness component can be added as a constraint to ensure fairness is considered during learning. In the end, we want the system to produce a fair ranking, a ranking that is more diverse and that does not favor one group over another. But how do you measure fairness? One approach is to consider the relationship between a candidate's relevance and exposure, as shown here. The idea is the candidates that are equally relevant should be equally likely to be shown to the recruiter. We will discuss approaches for measuring fairness in the full lecture. Thank you for your attention. More information will be available in the description of this video, including various ways of accessing the entire course.